Welcome to the MS Dev Show, episode number 205. This week we talk with Mark Fussell about Service Fabric and Service Fabric Mesh. Robots have replaced lawyers and GitHub contributors. And you can finally pay someone to review your website while they're drunk.
Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications. Check it out today at raygun.com.
This week we got Mark Fussell, Group Program Manager for Service Fabric, part of the Azure Core Compute team. Welcome back, Mark.
Great, thanks to be here.
Yeah, it's been a while since we had you on, and I saw you at Build. We didn't record an episode at Build, but we're like, oh man, we gotta get you back on to talk about Mesh. So I'm so glad that you're here.
Yeah, I'm pretty excited to be here. There's a lot been happening since Build, and there's a lot happening inside Service Fabric.
Absolutely. Carl, what do we have for the comment of the week?
Yes, I actually found a way to more easily check out the iTunes reviews from pretty much every country.
Yes, you did.
So this one's going back a little bit to February, but it's from the Norway version of the Apple Store, and it's from Hakan Dejejdi. I murdered that, but hopefully you know who you are and getting recognition. It says, listening to the last episode, I had my mind blown when they mentioned the Control Windows key and C keyboard command to make your screen go grayscale. Mm-hmm. And if you listen a little bit later on, we've got some related news to that, but we'll get to that in due time. If you want to get mentioned on the show like Haken, send us an email to feedback@msdevshow.com. Comment on Facebook, YouTube, or Stitcher. We really like those 5-star iTunes reviews.
Shout out to Norway. That's so cool. I mean, it's just really cool that people are listening to us around the world. It just blows my mind.
And it's pretty much everywhere too. It's amazing how much reach we have.
Yep. Okay, so let's jump into the news. We have a couple news stories here. The first one, I was laughing pretty hard before the podcast. It's theuserisdrunk.com. And do you want to describe what this is, Carl?
Yeah, this is a guy's side project. He says, your website should be so simple, a drunk person could use that. You can't test that. I will do it for you. I'll get very drunk and then review your website. And I'll send you my screencast and you'll get a video of me. And this isn't just some guy who's doing this, with unrelated skill sets. He's a designer and a full stack web developer. And you can look at the projects that he's done before and see reviews he's done for other websites. He's actually pretty good.
Yeah, he's finding bugs. And I mean, I saw one where, it's just hilarious because he just gets to certain screens and he's just sitting there like, he's confused. He starts clicking on stuff. The one he clicked on like this favorite button and then, it said, oh, it's been favorited. And then he clicked it again and he found a bug where it let you do it a whole bunch of times. He's like, click, 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 So it's also like the guy is actually testing your stuff too, which I think is really cool.
Yeah. So, and he's done quite a bit. And like, even if you want to look at this for the entertainment value, just check out the videos. But, if you might be in a situation that you could use his services, go ahead and check him out.
So how much is it, Carl?
He does have a price breakdown. What's really funny is you can have him do just drunk, just sober, drunk and sober, and drunk, sober, and with my mom.
Does he tell you what alcohol he gets as well? Like, is it more expensive?
Yeah, no, he does.
So you can, for an additional fee, you can specify the exact beverages.
Oh, I didn't realize that there was an option to specify. No, yes. I thought it was funny because the one, I can't say what he said because then we'd have to
profanity.
Mark this as not clean, but he's like, I'm drinking a Manhattan. And then there was some swearing after that, going into his reasons for drinking that particular drink. But yes, he does at the beginning describe what he's drinking.
But there's a big difference between Budweiser and 18-year whiskey or whiskey in terms of the cost.
Yeah. I wonder if the testing.
What class of drunk drinkers are you optimizing your website for?
Yeah, exactly. So, the high-end package. So the drunken sober package, which is great because he'll review it while he's drunk, and then he'll also do a sober private review afterwards. That's $799. But yeah, I mean, I love that he has all the previous videos out there right on the front page. So I recommend going and checking those out. I have a feeling I'm going to watch quite a few of those actually. Okay, what else we have here? A bot that is human competitive patches and automatic program repair with Repairinator. Oh, that's quite a title.
Yeah, I think there was like a few follow-up articles on this, but I tried going to the canonical source. So that was the canonical source. But really what this is there's this open source project bot called the Repairinator. And what it's trying to do is it monitoring several open source projects and using AI to find bugs, and then not just get a patch for a bug, but like a human competitive patch for a bug. So it's something that, sometimes you kind of do some code reformatting with a tool and you're like, yeah, that's definitely came from a tool. It's not something that a human wrote. This is trying to get something that's logically correct, but also looks like a person would do it. And then not only that, but they're impersonating a human. It's looking like a human did this, not that a bot did it. And they've gotten several pull requests that have been successfully merged into other projects, done in a pretty quick process. So what they're specifically looking for is when something happens in an open source project, a CI/CD process kicks off, and they're looking for failing tests. And then what they're trying to do is using AI to correct code to make that test pass. So they are trying to, put some logic in there to really optimize for, hey, I know I can say this is correct because there's some sort of, test that's backing that up. But going from January through June, I don't know if they've had more, but they specifically say that they had 5 pull requests that were accepted. And they've included like comments from whoever accepted them, ranging from thanks for the patch to it's just merged, or cool, thanks for going through the Eclipse process and for the fix. So, some of them were, these people were, thinking that they were accepting these from an actual person. Mm-hmm. So I think that's where it's pretty interesting that, on the internet, nobody knows you're a dog or a bot. Mm-hmm.
Yeah. Robots are people too, Carl.
Yes.
So I don't know. You just got to be really careful, because what happens when this thing starts patching itself? Is hopefully it's not a maintainer of its own project, because that's the thing we need to watch out for, guys. This is super cool. Like I am fascinated by the fact that it's able to find these. I mean, this tells me, I know there's some things like built into Visual Studio that do this. Just tells me that we need something a little bit stronger in there, right? Like something that pops up and is like, wait a second, like you screwed up and I know how to fix this for you. Please trust me. But like you said, I mean, people just don't trust the tools as much as they trust other humans. So, yeah, that's a tough challenge. We need like Amanda Silver, like a fake Amanda Silver to like Skype in and be like, hey, there's this thing wrong with your code. I don't know.
It's pretty good if we could take some of the more typical bugs that you find, that's some more menial ones, and then you just focus on some of the harder ones. That's what I think about it. Yeah.
Because I have seen like AI for like finding and fixing bugs and matching with Stack Overflow and things like that. So, I mean, this is like this. I think this is going to be a pretty big revolution in IDEs, right? I mean, it'll tell you, hey, I see what you're trying to do, and you just made like 5 silly mistakes. And like I said, I think the key thing is here's how you could easily fix these. Would you like me to fix them for you?
Yeah, it's the personification of IntelliSense in Visual Studio.
Exactly.
It's that turned into a bot.
Exactly. Bot IntelliSense. Cool. And then speaking of AI, we have 2 sort of related articles. AI versus lawyers, the ultimate showdown. And this is an infographic. Do you want to go through this, Carl?
Yeah, we're going to have both an infographic and the article that it came from. So feel free to compare the two. But, in a very similar thing, non-disclosure agreements are something that lawyers have to deal with. And they're kind of mundane. They're kind of similar, but, they're all different. So what they did is they gave 20 top lawyers in the US these 5 different NDAs to go over and look at. And they also gave this to a bot to process. And just kind of looking at this, so there is 5 different NDAs. It took an average for the lawyers 92 minutes to process all of these. It took the AI 26 seconds to do this.
Yeah, that's crazy.
So there's definitely a speed thing here. There is also, I think, 30 different legal issues across those, 11 A4 pages, 153 paragraphs, 3,213 clauses. And the AI had a slightly better accuracy level, 94% compared to 85%. So, I mean, what I really like looking at this compared to the bot that finds bugs. And, there's a lot of mundane things that we do, like Mark said, all those little bugs that, we could catch. But if there's AIs there to get the simple stuff for us, then we can concentrate on the harder, meatier work. And if AI could be tuned, not to replace us, but to make us better, that's where I see that, people's acceptance of AI really expanding at a quicker pace.
Yeah, I think this is a good example of where, like, it basically can flag things for you, right? It's like it will say, hey, you really should focus on these. I do worry then if this AI is available to everybody, then are we going to get this thing? You know how you get these like emails that look like they're like a jumbled mess, or they have like some subject that's like totally unrelated. It's because they know like what actually gets through spam filters. So are we going to start? Is the legal jargon going to start getting worse and worse? It's like, oh, they're going to find this thing, but if we bought the same software they did, so we'll obfuscate it a little bit. We'll run it through until it doesn't detect it, and then we'll send over the contract.
Yeah, I mean, I think that deviates a little bit from the point. I mean, that's a way to use it maliciously, but like, let's look at like, how automotive companies are getting AI into the vehicles, because people don't really want, at this point in time, at least mainstream, like fully automated drivers, but they're really comfortable with that dynamic cruise control, lane assist, where it keeps you in your lane, that blind spot detection, all those little things, that parallel park features, all that stuff that still takes a lot of processing power, a lot of intelligence to control those accurately, but yet leave you in the final control of what happens and what's done with the vehicle. So, you look at these, how can we use these different AI things to really augment us and make us better at whatever task we're doing? I think that's where AI today can shine.
Yeah, I completely agree with that. I see that happening a lot, where it takes on, and it makes you think a little bit more differently, and it makes you it pushes the boundaries of what people are capable of as well.
Yeah, I agree. I think it's a little challenging because I think, Mr. Terrible Lawyer here, the lowest performing one, like he scored a 67. So I think what you guys are saying is like Mr. 67 there, he does his legal review and then he runs the software and he goes, oh crap, like there's 3 things I missed that could have cost my company millions of dollars. So he goes back and, he figures those out and that makes him better. But
it's like spell check for lawyers. Yeah,
but I do worry about the flip side. So spell check is a good analogy. Has spell check made you a better speller? Like I think it's very debatable. Like there are some words where I'm like, man, I know I spell that wrong all the time because spell check keeps picking it up. But at the same time, there's things where I spell it wrong. I'm like, spell check got it. I'm good to go. Yeah. So, I'm worried about something like this where they're like, I'm going to have the AI take a pass at it. And then I just cut my work in half because I can just go investigate a couple things here. So I think we're going to struggle with this for a long time and how to integrate this in. I mean, I'm always like pro technology, like the technology is going to win. But I'm not sure how it will play out in this particular case. This type of AI should be interesting. And I guess that the same thing could be said for programming, right? I mean, I talked about it finding, hey, you had these bugs, so now it's like, wow, I can double my programming speed. I can write a whole bunch of sloppy code, let the computer pick it up and fix it.
But let me give you the controversial one. What if the medical doctor, because basically this is looking at a huge source of information becoming better. What if the medical doctor was made sure that your analysis of your results was 95% accurate instead of 67% accurate? You'd want that.
Well, I believe that today there are the Watson AI. When doctors opt into using Watson AI to confirm their diagnoses, they have to accept what Watson gives it. Yeah. So That's interesting that it's in those terms and conditions. Like if you disagree with Watson, you have to still give its recommended approach.
And they've shown this, like they've shown AI running on cancer results and things like that, and there's little differences that it find that a human might have missed otherwise, or gives them at least a second view.
Yeah, no, that's what I want to happen, right? I want my doctor Googling, right? Like I want him typing
Exactly.
I want him typing in my symptoms and being like, oh, it's this. Unfortunately, like that's not really what happens. Like, what ends up happening is somebody else does the Googling and then they're like, oh, it's this. And they've like misdiagnosed it. And then you go to the doctor and the doctor like doesn't look at that because they're smart. And they're like, you have a fever? Obviously it's an infection. Here's some antibiotics, be on your way, So it's like, they can be used in combination to do the right thing. I hope that is actually what happens because I worry that it's going to, it'll make people lazy. Like I said, the spell check is just another example of that. Does that make us better? Probably. It probably makes the end results better, but does it make people lazier? Maybe. So anyway, we probably already spent too much time on that one. Unless there's any final comments, but otherwise I'll move on. What do you have here? Pull request successfully merged, starting build. Oh, this is the GitHub thing.
Yeah, I thought that was a great title for the GitHub blog. And so for those of you who do not remember, Microsoft was buying GitHub, and that started several months ago, and it takes a few months to get through all the paperwork and lawyers and governments and all that. And actually today, as we're recording, the 29th of October is when it finally goes through and Microsoft officially maintains ownership of GitHub. Woo. And along with that, Nat Freeman becomes a CEO.
Yep. Of GitHub.
Of GitHub.
Yeah. It's funny because, you mentioned pull requests and I can't help but think of our previous story. Like I hope all those people over at GitHub are not bots and that this was automated. Hopefully this was submitted by a human. But very cool. And then actually the other news story they just thought of that was just breaking just the other day or just yesterday, I guess, was that, I'm totally blanking on it now. IBM purchased Red Hat, that was, I'll let you go out and read the comments for yourself. I won't even repeat any of them, but that was, that's interesting. People are not too excited about what the future holds for Red Hat, but we'll give them the benefit of the doubt and we'll see what happens there.
Yeah, just to give a few more details to people who aren't going to search for that. Red Hat has a lot of cloud-based technologies. In particular, I think OpenShift is one of the biggest ones, and IBM is really trying to make themselves competitive in the cloud landscape. So by them buying Red Hat, that gives them potentially a huge boost in those areas, but it also puts into kind of worry, what's going to happen to those technologies? Are they going to stay, freer and work cross cloud, or is IBM going to make those a little bit more of a works better with IBM pieces?
Yeah. And to be fair, like people had the same concerns with Microsoft buying GitHub.
Oh, yes.
So, people just worry, like don't destroy the thing that I love, please.
Yeah. So. I think that when you look at the track records of the two companies in recent times, Microsoft does have cases where it can point back to where it, kept those products and companies and teams intact and going, whereas people are a little bit more concerned about IBM doing the same thing.
Yep. Okay. Well, let's move into the good stuff, which is Service Fabric. And I actually the first thing I was going to ask you what is mesh, but I think we actually have to take a step back. I mean, we did have an episode on Service Fabric, but maybe you could give us like the 60-second overview of what Service Fabric is, just for anybody who hasn't been exposed to it.
Yeah, that'd be great. Service Fabric it's a service that we host today, and it's got a set of we call it a microservices a platform. The convention nowadays when you build a service pretty much is that how you build a service that you want to run at scale is you use a microservices architecture approach. 3 years ago, people were debating, is that the way you do it? But by now, most people have accepted that if you want to build a service that runs at scale using a Microsoft design approach, whereby you break code down into smaller pieces of code, that makes it more agile, and you can make teams independently, and you scale individual pieces, is the way it works. And Service Fabric is a microservices platform. It includes how you run your code, as well as programming models to develop against it all. And we use it extensively to build those services at Microsoft. And then we have hundreds of thousands of customers now who are using it to build their own services.
Okay, cool. That was going to be my comment. Was I know it was used extensively within Microsoft. So it was a first party solution, and then it it was one of those things where it's like, hey, lots of people in the world could could benefit from this. So I'm glad that it's out there in the world.
Yeah, that's exactly. That was always the goals actually of the program, was to kind of use it internally, and then give it away for everyone for free, so they can just use it.
Very cool. And then we should dive into Mesh. So that's what it was announced at Build. So what is Mesh?
Well, what we found when people started using Service Fabric, we have two offerings of it today. We have one version which we call Service Fabric Standalone, where you can take Service Fabric runtime and you can go off to your own data center. You can install Service Fabric there, and you manage the hardware, as in you find the physical machines. You have to set up this cluster, which is the thing where you put your code and you run your application, and then of course you build your application. So you have to think of three things. And then we had an Azure offering where we call this dedicated clusters, where effectively, obviously you don't need to have a machine anymore because Azure provides more, but Service Fabric will set up a cluster for you and you build your applications. Well, even that, we found that people had a hard time managing the cluster itself, scaling it in, scaling it out, having to think about how you patch the OS. And there's a lot of control that you get being able to have that cluster. You see the types of VMs you can choose, but there's additional overhead there. Service Fabric Mesh takes all that away from you. So you have all the fun and excitement of simply building application. And then what happens is Microsoft, stand up big clusters of machines. We manage the clusters on your behalf. And then you just simply build the application now with a microservices pattern in ARM and deploy that into Service Fabric Mesh. So
yes,
that's really what it's about. Yes.
That's what I think that's what obviously that's probably what the majority of developers want, right?
Exactly. Yes. Yeah, exactly. I mean, the other way to think about Service Fabric Mesh in a nutshell is it's a first class ARM model, as in Azure Resource Model, for designing a microservice application, an application that consists of smaller pieces of code, services, and you give that to Azure and tell it to run it. And it runs it at scale, and you can update individual pieces. In fact, with that regard, you don't even know it's really running on Service Fabric. Kind of Service Fabric really, to some degree, is an implementation detail, because you just simply are describing this application. And what happens with Mesh is it takes this application, it launches it inside containers, inside Hyper-V containers. It puts an isolated network around it, and then exposes an external ports or a number of ports through the Azure Load Balancer. So all this configuration and policies that you want done is described to you of how you want to build your application.
So if I already have something that's set up and working in Service Fabric, one, can I move that to Mesh? And two, should I?
So the answer is right now today we can move certain applications, but not all of them. One of the great benefits we did provide in Service Fabric today were these two very productive runtimes, one called Reliable Services and one called Reliable Actors. And they allowed you to build these microservices apps. At this point in time, we are going to make those available in Service Fabric Mesh in due course, but they were actually quite tightly coupled to the cluster model that we had. And so that makes it a little bit tricky to move some of those across. So moving them directly we're working on it. It's not possible right now. What we have to do instead is we've done some things to help you migrate some of those existing applications much, much more easily. Going forward, right now, Service Fabric Mesh is still in preview. We're going to be spending probably at least, it won't GA until next year. So we've got a public preview program around all that. And it's mostly designed around for you to take, one of the goals of Service Fabric is actually to allow you to have any runtime. So we want to open it up so you can bring any framework, any runtime of your choice, and not be necessarily tied to any specific runtime that we provide. So yes, in the longer goal, you'll get there for moving some of your existing applications. Right now, mostly is bringing your own runtimes and the application models that you want to bring.
Okay,
yeah, so
makes sense.
Yeah, so I know with Service Fabric, you have a lot of control with exactly what's going on with your application and the infrastructure. What are you giving up in order to work with Mesh? Or is it kind of like you do less and you're responsible for less?
I'd actually say you're not giving up anything. The only thing that you're giving up is this control over the visibility of the machines that you used to see before. To a large degree, because what happens with mesh, here's the important thing that everyone has to really understand is we're slowly going up the abstraction levels to build applications. And people really don't want to start thinking about managing infrastructure and machines in any way. And what they want to do is think about building applications and services. So, what you're really giving up is that lack of control over the machines itself. So here's what some customers might want to give up. There are customers who have to run specific VM images. Their company says, I have to run this particular VM image. Well, in Mesh, you might not want to run that particular image. Some customers have to say, I have to run this virus checker on these set of machines. And that's where you probably have to drop down and probably use the Service Fabric cluster environment because you want direct control of the machines. But if you don't, we're actually starting to build a lot of our services in Microsoft on top of Service Fabric Mesh itself. So that's the level of expecting scale that we'll have. New services, we want to say, don't manage your own cluster, build them on Mesh, and we'll have one platform that you can build even large-scale services on. Things like Intune. We fully expect Intune, MS Teams, Microsoft Office 365, all these customers actually to build on top of it all internally. And so I would say that really you're not really giving anything up, but you're actually freeing yourself up to be more productive.
Okay. Whenever I think about this really reminds me of Azure Functions, where I just have some function code and I just say, you go and execute it for me. So I'm wondering what is like the smallest piece of functionality then that works with Service Fabric? So if I want to create a microservice, is there like a whole bunch of ceremony around that? Do I have to like create a container, or is it just some code that I can deploy easily? What does that look like?
Yeah. So the simplest thing that you can run is a single container instance running inside a single app. So the way it works is you have an ARM definition. You describe an application inside ARM. So think of any of the resources you see inside Azure today with its resource model. You can have an application as a service type, the resource type called Service Fabric Mesh application, and it can contain a single service that has a single container definition running inside it all. So you can run a single container instance that runs inside this application. And so that's typically what we would see is that if you want the simplest type of application, and if you go to our tutorial, we have a Hello World application there. And all it does is it deploys a website that says Hello World Mesh. It runs that inside a container and launches that as part of your application. So the key is everything is run inside containerized images. All of those get built and pushed inside to a repository such as the Azure Container Repo or Docker Hub. You pull down all your individual containers that are running for every single one of your microservices, and those all get constructed inside an application. But the great benefit that you get from Mesh is not just the fact that it runs a set of containers in an application model, but it provides other services as part of this. One of the most crucial things is that we have this intelligent routing service that allows you to do calls between the microservices on the same set of application or across applications. So this intelligent routing allows you to do communication within your application or across applications. And there you can start to do things like send 20% of my traffic to this new instance of the service, to blue-green deployments, communicate across services. And all of this actually is built under the covers on top of Envoy, which is a reverse proxy that we've used to do this communication framework.
Okay, I'm trying to keep up here. So I'm looking. I found the resource provider or the template for Hello World,
yes.
And it's pulling down Azure Mesh Hello World. So basically, I guess one thing I wanted to kind of confirm. So this is just a Docker container, right?
It's just a Docker container.
Okay.
Yes, everything gets built inside Docker containers. So the experience is you as a developer, you write some code, you write it with any framework of your choice. Use Python, use Go, use the .NET Core. Build your applications, build them all into containers. You can use communicate between them just with those standard HTTP endpoints.
Okay.
You can wrap those all up into into individual services, which are described in the ARM model. Put those inside the application. Open up any public ports that you want through the Azure Load Balancer, and then deploy. So it's as simple as that. That's what I'm saying. There's really nothing special about it other than, you actually have this very well described application model, and then you have all of these higher level services to provide routing messages between your individual microservices.
Well, that's pretty awesome.
It's super awesome because it makes it super productive. And then what actually happens is that there are then other services that get provided that you can take advantage of if you want to. So, for example, Service Fabric Mesh provides lots of storage options for your container. One of the toughest things today is to create, how do I store all the state with my container? Where do I run it all? So out of the box, you get volume drivers for your container. Now, Service Fabric Mesh provides you two. There's one that allows you to attach Azure file storage, so you can write everything out to Azure files. And then we provide this built-in one called the Service Fabric Volume Driver that allows you to store your state onto local disks and replicate it between those. So it deals with like hard problems around the storage replication, for example. Another thing that's super cool that it does is that every single one of those services has security identity associated with it, or managed security identity. So now you simply deploy your application. It can go and reach out to Azure Active Directory, get an identity associated with it. And so now you can communicate to your Cosmos DB database, for example. So those kind of built-in capabilities of giving you identity at the service level, giving you the ability to have storage attached to the actual container itself for long-term persistent state, are things that you get out of the box that make writing applications even easier.
Okay.
So I was also looking into this, and it was talking about how Mesh can detect and deal with failures. What exactly is it doing there?
Well, what that means is that you get to describe your application. You have it's a set of these services which have containers. You deploy it and run it. Now, this is running under the covers on a large Service Fabric cluster that we host. But say for some reason there's a bug in your application and the application crashes, or say even the physical machine dies and is inside the data center. Service Fabric Mesh is responsible for restarting that instance of that application or that particular service, launches it on another machine, and will hook up the communication to it all again. So as far as you're concerned as a developer, you will always make sure that the availability and reliability guarantees are there. So that's one of the key tenets of the entire platform itself. We'll always make sure that everything that's described in your application is always running. And then you can scale things out. So say you have an application that consists of, an instance of one service, and you say, well, I want 10 instances of this service. All you do is an ARM deployment. You just say, instead of one instance, I want 10 instances, and we can scale it all out. So there's this availability, scalability paradigm that allows you just sort of to scale out and deal with failovers.
I do want to talk about that scale a bit more, but first I did want to understand the way that this service works and the way that you sort of set it up really reminds me of Kubernetes, or specifically like AKS, the Azure Kubernetes service. So like in your mind, what is the difference between this and like AKS?
Well, the difference between this and AKS today, AKS is a fabulous service. Mm-hmm. In fact, I actually work on the same team as the AKS team, so we actually all work very closely together. But AKS,
that's actually great to hear, by the way. I mean, that's really cool.
Oh,
It's not like, those dang AKS people.
Oh no. In fact, now the AKS team and the Service Fabric team, and actually even app service, are all very much aligned in the same team. So we regularly try to align capabilities across these things. So we work very closely with the AKS guys, and we're actually trying to share as much we align things. So, for example, they have a thing called Open Service Broker that they're developing, which allows you to abstract away a call to a particular storage thing across cloud platforms. And we're integrating with that. That's cool. One example of how we're working closely. But the way I look at AKS today is it's closer to what Service Fabric, the clusters are today. You set up this cluster, you set up this environment, you're still responsible for scaling this cluster in and out. You still get to see the machines you're running on. It doesn't take any of the application deployment. There's nothing to do with describing applications in Kubernetes. It's still your responsibility to go off and decide what framework you're going to use and how you're going to build all that. And you have to sort of stitch that all together and create your own application platform on top of that. Service Fabric Mesh is a level of abstraction above both of those. It's a true microservices description of how you deploy an application into Azure. And these capabilities of the intelligent routing between services, the storage attachment to the containers, the ability to open up public ports to your application, update the number of instances, means that you don't actually see anything to do with an orchestrator. In many ways, orchestrators, I predict in about a year and a year's half time, will be boring and uninteresting because you don't really want to talk at that level.
No.
You're trying to build your application level. So that's really the fundamental difference, is that, it allows you to not have to manage any of that infrastructure that you have to do with AKS today and you have to do with Service Fabric, the clusters today. But it takes you just purely into the build my applications instead of individual microservices approach. That's the fundamental.
I really like that because, AKS worked great. Like I just ran a command line and boom, I had this cluster running, but then it was still this thing that I have to babysit just because of how Kubernetes works, and then I get some weird error and I'm like, okay, searching, for Kubernetes and this like error. And then I find a Stack Overflow thing and, Kubernetes is great. Like I'm definitely not bashing Kubernetes, but at the same time, like I just didn't want to have to babysit Kubernetes.
Yes. Yeah. Kubernetes is fantastic ecosystem. There's a lot of excitement around that. The Azure Kubernetes service is growing very, very fast. We're very excited about how that's doing so well inside Azure at the moment. But, at the same time, you want that complexity taken away from you. And this is exactly what we've seen, which is why, in some ways, the Service Fabric in mesh really ought to be diluted down. It's really just a microservices platform of how you build an application and deploy it into Azure. It's not really, strongly tied to Service Fabric in any way. It's just that's a way of describing your application. So yeah, that's the thing that we see all the time. Once you've still got all this complexity of building like a front-end gateway that does the routing up to all your individual services. You have to deal with the failovers. You have to deal with the discovery. You have to deal with the telemetry and the diagnostics. How do you do A/B testing? How do you do security? How do you do certificates management? All those other things that go far beyond just the orchestrator itself.
Don't wait for users to report problems. Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications, supports all major programming languages and platforms, and integrates with your current development workflow tools too. There's a free 14-day trial, and it takes minutes to implement, so start resolving issues in your application and check it out today at raygun.com. Just to kind of like really nail down what the scaling looks like, how does it know, or how do we configure mesh that says, hey, I need at least minimum this or maximum this so I can stay within budgets? Or, can you have an open-ended like, hey, that's Black Friday, let's remove all limits and make sure we don't go down?
You can do exactly that. So in the ARM definition of the application, you describe, here's my application, and here's service number 1, and here's service number 2. Each service, you can, again, just have a property inside there that says launch 2 instances of this service, or you can launch 10 instances of that service. And then every one of those services, because it runs inside a container, you can put resource constraints on it. So you can say this container only uses 2 CPUs, and I want it to have 1 gig of memory. So those resource constraints, and at any time you can go into the ARM description of your application, resubmit a new ARM model in the idempotent way of ARM is inside Azure, and simply say, instead of having 10 instances, I want 1,000 instances. We, inside Microsoft, inside the Service Fabric team, manage the clusters, and as the clusters start to grow and more scale pushes out to that, we'll expand the capacity of the clusters that are available. So, for example, as we get closer to Black Friday and we see that more and more people are pushing the boundaries of their application because they've changed it to say, don't run 5 instances, run 1,000, we'll expand the underlying physical clusters that your application is running on. So for you, you don't know how it's running. It's simply there's a multi-tenant environment where you deploy your application, and there is unlimited scale of how you choose your application. You can also set rules that say, when I hit a particular threshold, scale up and scale down. Those are policy-based driven rules, as in most things inside Service Fabric Mesh. So, for example, you'll be able to say, when the number of requests per second come into my application hits over this particular threshold, I want you to spin up 2 more instances of my individual microservice, or if the number of requests per second drop below a threshold, spin it down to this particular number. So all that's happening inside Service Fabric Mesh is we're spinning up new small containers across this extremely large cluster running under the covers view, and making sure that all those things are isolated and secure, and that container startup time and shutdown time is very fast, which is where we're spending most of our work to get you very fast startup and shutdown times for the containers that run today. Whether those are Windows containers or Linux containers. And the beauty is you'll be able to mix and match. So I can describe an application that consists of Windows and Linux containers.
That's cool.
Use any code I want. One's written in Go, one's written in Python, one's written in Node or .NET Core. Deploy them all inside this environment, and just communicate over my chosen protocol, like HTTP, and then spin up instances and spin them down.
So then, keeping on with the Black Friday example, let's just say Black Friday is really kicking in and I've got tons of people hitting my site, but I notice something's wrong with it. Does Service Mesh allow me to update my website while having 0 downtime when I'm in those crunch times?
Correct. Yes. So that's the other key element around this all, is we spent many years building in Service Fabric, the underlying technology, how we do rolling upgrades across your application. So the interesting part about Mesh is that we take away a lot of the pain of how to manage those versions for you. So before inside Service Fabric today, you had to sort of update the individual files to put versioning changes inside it all. With Service Fabric Mesh, because it's just a new ARM deployment, we track all those ARM changes for you. And now, if say you're at a bug, so you realize, I'm going to push out a new change for my website in time, you will build a new container image for your application, push that out into your repo, submit a new change into Azure. That rolling upgrade will start to roll out, and it will make sure it'll pull down the new container, start it up on the machine, direct the traffic to that, pull down, make sure the old container shuts down gracefully, and direct the new traffic to that. And so you can do a rolling upgrade across the set of machines, making sure that you've deployed new code with no downtime. So yes,
that's cool.
It's a pretty cool capability that is, especially because you got to make sure that there's no interruption in any running service.
Yeah, I know we talked about Hello World before, but if I've never taken the time to actually learn Service Fabric, and I'm like, wow, this mesh thing sounds pretty cool. Is that going to be pretty easy for me to pick up? And is my lack of Service Fabric knowledge going to be good or bad for me?
It's actually a lack of Service Fabric knowledge is kind of not really that relevant. That's the interesting part of this. Okay. The thing that you really want to be able to get good at is building things with your favorite programming language and your framework, building them into Docker containers, and then really deploying those through the ARM definition. There are some particular pieces of it that we've done to make sure that some of the best capabilities of Service Fabric today are available inside there. So, for example, one of the key areas from a developer perspective that we've improved a lot, that was a key value add that Service Fabric provided, was state management and these reliable services and reliable collections. So we had a lot of people come back to us and say, when I build applications today, I use your programming model called reliable services, and I have to derive all from these base classes. And it gets kind of a little bit invasive. Instead, we took all those reliable collections that allow you to replicate a state for different data structures like a queue and a dictionary, and separated them out into separate NuGet packages, for example, for .NET framework. So now I can go into any .NET application, pull in some NuGet packages for these reliable collections and use them that way. So that's kind of the value add that you get from Service Fabric. Okay. But if you just want to get an app up and running, you don't really have to know a lot about Service Fabric.
That makes a lot of sense having those as separate packages. I always wondered, because they never seem dependent on Service Fabric specifically, like the reliable collections. So maybe they were. I don't know how they were tied in, but I'm like, man, I just like to just be able to use these things.
Exactly. So what happens now? So now what's coming is I can go into my Java language and pull in the reliable collections and get these replicated state structures. I can go into my Node application, pull them in. I can pull in. We'll do it for Go. We'll do all these other different languages around this all.
Cool.
And I think that's pretty cool, actually. That makes it now so that you can really decide if you want to use these replicated data structures for some of your state management, you can. So that's kind of some of the aspect. The rolling upgrades of Service Fabric is key, but mostly we've talked about how we sort of enhance this microservices platform so that you have to not necessarily know anything about Service Fabric to a large degree.
Man, you're getting me really excited about this. This is awesome.
It is awesome. Actually, it is incredibly easy because we've been showing this to developers and saying, look at this. We've done some great integration with Visual Studio as well. So we're closely working with the Visual Studio team because ARM, is not the favorite environment necessarily inside Visual Studio. We've also done inside Visual Studio, we have just a YAML description for your services.
Oh, that's
as well.
great. Okay,
cool. And that way you can work inside Visual Studio or VS Code. Both of them very well integrated. You can use YAML just to describe your application and services. And then under the covers, we just translate that to ARM as well. So as a developer,
cool.
That's pretty cool actually. So as a developer, you could choose this other. We'll introduce other formats maybe, but at the moment it's done YAML. If you want to work with the ARM, you can. But this is super cool now, so I can go in there and just describe my application. You get full container debugging on your local machine. This is amazingly cool. You're inside Visual Studio. You can take an ASP.NET Core app. You can say target inside mesh. It immediately adds the Docker file, builds it all into containers, runs it on your local machine. And you have almost seamless debugging of your containers, Windows containers, all Linux containers inside Visual Studio for your mesh application. And then you can just right-click, publish, deploy, either through Azure DevOps or directly from Visual Studio into Azure Service Fabric Mesh that's running inside Azure. And that makes it pretty cool, actually, as a developer experience. So we've been showing this off quite a lot, and people have been going, oh, wow, that makes it incredibly easy for me to build these container applications now. As an application that set these microservices and then just deploy them for me. Especially now we have all this intelligent routing that allows you to do the communication between your services. And I think that's the important point, because the other comparison that we get is people say, well, ACI, I have Azure Container Instances today. How's that different? Well, ACI, I think of it as just like they're these single containers that run.
Yeah, it's a whole bunch of silos.
It's a whole bunch of silos.
Exactly. That's why it's never been that appealing to me. Like I have run, everybody thought I was crazy when I was like putting everything that I have into Docker. And so like the MS Dev Show website, for example, actually runs in Docker. But like we're ready to go. Like we can run on Mesh today.
Yeah. So that's what it is. ACI, the way I think about it is ACI is to it's like individual VMs, but for container world. So you're going to think, but there's no concept of an application. If you think about
you got to wire them up yourself.
If you think about Service Fabric Mesh, it stitches them all together and gives you all the intelligent routing, the storage, and the identity associated with them. And all of a sudden you have that, then you're away.
Yeah, because I ended up to get it, because I have gotten our website running in like every possible variation, including ACI, the Azure Container Instances. And what I ended up doing, just because the wiring up like Nginx and like one container and then like Node in a different, or actually it wasn't Node, it was actually we're using static files, but I was using Express. Well, anyway, I was using like multiple pieces, and the way that people normally do it is you have like one container that is the site, and then you have another one that's sort of this front end proxy. But I'm just like, well, that's a pain, because now I have to like have like a YAML file for that. And then I guess now I'd have to have a different one for Mesh. And then for ACI, I'd have to run 2 different ACI instances, and then I'd have to wire them up manually. So I just jammed everything into one container, which I think is like an anti-pattern. But so this is much better. I like this.
Yeah, exactly. I mean, today, whenever you have any ingress data, you have to have that sort of gateway thing, whether it's Nginx or HA proxy or Kestrel or Traffic or Envoy, and you have to have those things. Well, if you imagine that one of those is built into your application in Service Fabric Mesh and you don't see it, and all you describe is, I want to run a policy file. So the idea of Mesh is mostly that you describe things through policies, like route these traffic from here to this service, or turn on these resource constraints. And now you take away all of this pain of having to build these infrastructure things yourself. Cool. So that's the cool part of it all. Yeah. So we're pretty excited by this all. We have a whole bunch of internal teams building on it. So, for example, Linux functions. Linux functions, as in functions to runtime. When you go into
Right.
Azure, you do Azure functions. They just announced Linux functions as a public preview at Ignite. That's all built and running on Service Fabric Mesh as an internal team we're doing. And then we're working with a lot of external customers who are also building their services on this now, and testing inside, giving us lots of feedback, and really having quite a fun time, enjoying themselves. Just going straight into the application development.
Cool.
So, as somebody who's interested and focuses on IoT a lot, I've heard that Service Fabric is coming to IoT solutions. What does that look like?
Maybe you know more than I do. I know that I was told that at least 30 to 40% of all the IoT deployments inside Azure use Service Fabric as the backend. Certainly, all of the high scale ones do. And when you hit to some certain scale limit, that's where Service Fabric becomes the best choice.
Well, there's two pieces. There's that piece, but then there's also on the edge, I think is what he was asking about.
Oh, on the edge. Oh, I see.
Yeah.
Yes. Yeah. Oh, well, that's a... Yeah, so that's the back end that if you build things there. On the edge, there's another interesting side of it all. Mark Razonovich at Build did a great demo. If you go and look at his data center talk at Build, he showed Service Fabric deployed onto edge devices, so that we can run Service Fabric, say, on Raspberry Pi machines or smaller pieces of compute. So now, if you imagine that I could build an application and I could deploy it inside Azure, but at the same time, I could set up machines on the edge and deploy exactly the same application there. The key element there is that Service Fabric provides you the reliability across a set of machines. So let's give the scenario. One of the scenarios we were given was sometimes there are 3 or 4 cameras that are all linked together, and one of them wants to do some more data processing than the others. But you can take advantage of making the compute of all the cameras linked together, so I can use the compute from all of them to analyze the images from one of the cameras better than the others, and so they become clustered. Yes,
that's cool.
And so now, rather than all of them having to be powerful, one of them can just they can distribute the image recognition software across them all to see what's happening. Or if you just want to make things more reliable, so for example, we've seen a lot of people now bring machine learning to the edge compute. And so there are scenarios, for example, where oil companies are using machine learning on oil pumps in order to figure out the best way of pumping the oil out of the pumps. Before, they used to get someone who used to tweak the pump and things like this. Now they have a machine learning model running on the edge, but they want high availability there in the hardware. They don't want one machine just to die and their machine learning model fails. So that's where Service Fabric is also going on to edge.
So it sounds like Service Fabric, like for like a base install, they must have like super low requirements, is what I'm hearing.
It has. Part of it, actually, part of the project we're doing for Edge is we're having to strip down some of the unnecessary things that you don't need at the moment. When you go and stand a Service Fabric cluster up inside Azure, we hook it up to automated patching, and we hook it up to we turn on this chaos testing by default, and there are a bunch of additional services you don't need running on the edge. At least they're optional. So a lot of it has to do with stripping, so the minimal pieces down to run onto the edge.
Yeah, which actually, this might be a really stupid question, but the camera thing made me think of this. So if you have 3 cameras and then you buy a 4th, I mean, is it sort of able to join the cluster, or is that not something that happens like automatically?
Oh, no, that's exactly the goal. The goal is there's a piece of hardware that's been sitting there on a shelf for, a couple of years. Someone takes it out, they plug it in. It uses a hardware identification to initially download some packages to get it booted up securely. So that's all done through sort of IoT Hub. And then it reaches out into after talking to IoT Hub and getting sort of local secure packages to say, it gets configured to join into a particular Service Fabric cluster and then download applications onto it. So yes, the whole idea is it's sort of plug and play. To plug in a new camera, it discovers where it should be running, and it joins into the set of other machines inside all that.
Oh, that's really cool.
That's super cool, yes.
Yeah. Because I'm just, I want this future where like everything in my house is like combining, right? Like I'm running this new ML algorithm and it's like using the CPU in my TV to like assist.
Yeah, exactly. Yeah. Well, that's the goal. Well, going back
Yeah.
to all that machine learning we were talking about with, that's, when you want that lawyer, it should take advantage of everything running inside your house,
Yeah.
So, that's the
Yeah.
idea. Today it doesn't do all of that. The more you hook these things up, the more they kind of sort of can talk to each other and the more they can sort of offload work. And if something fails, another thing does. So that's the goal. Especially as you see much more of this machine learning running on edge devices.
Everybody laughs at IoT toasters, but who's going to be laughing with all that extra processing power I'm getting?
Exactly. So that's the cool thing around this all.
Yep.
But yes. So ultimately, the idea is that if I build something in Azure, I can deploy it on the edge as well.
Cool.
So that's pretty cool. And then other things that we're doing inside Service Fabric generally, we're just making the platform more robust, more scalable. If you're a Service Fabric user today, we're making it run across availability zones. We're integrating it across managed service identity, so you can get identity for the actual application running instances inside there, and generally making sure that your current offering has all the advances happening inside Azure in terms of particularly around availability and reliability inside there.
Super cool. Okay, so how much is all this going to cost me?
Well, actually, the good thing about Service Fabric Mesh is that it's all priced per second for your containers, how they run, based upon the CPU and the memory they use, and that's it. So you decide to say, if you have an application that has 5 services inside that, and each service uses, say, 2 cores of compute, so you could say 10 cores, and then they do say 20 gigs of memory. You just pay for the number of cores and the number of compute on a per second billing basis. And if you scale your application up, you pay for more. If you scale it down, you pay for less. And it's simply a meter around compute, memory, and if you use the Service Fabric storage technologies, you can pay for the compute inside that. The storage inside that, which is at mostly the same cost as Cosmos DB for highly available replicated storage.
Okay.
And so that's all you pay for. So, and it's per second billing. So as soon as you scale it down, you can scale it back up again, and that's all you pay for. We're looking at particularly the pricing. A lot of people have been talking about, as I scale out a large number of instances, can I buy the compute in advance? Yes, you can. As you buy your normal, you get discount rates for purchasing compute in advance.
Or like reserved compute.
Reserved compute, yes.
Yeah.
You can do reserved compute prices, and so you can get reduced prices across them all as well. So that significantly reduces the cost if you want reserved compute around them all.
Okay, cool.
So it's pretty cool stuff, actually, especially the per second billing. And this very much fits into, in fact, all of this fits in very much with our serverless offering. So another scenario that's a key element around this all that we're working very closely with is that we've already shown that because you can run any runtime, we're going to be thinking a lot about how we run Azure Functions inside this. Today, of course, Azure Functions 2.0 that we released at Ignite runs inside a container. If you want to use that as your favorite runtime, go for it. We're continuing to work very closely with the Functions team now, who will say, I want to build an application and I want to just have one of my services use Functions and another one use Node.js. And now I get the debugging experience inside Visual Studio, debug it locally, deploy it. That's super cool. Yeah. And then there's other super cool scenarios because Service Fabric Mesh fits into our serverless technologies. We're making sure it works very well with Event Grid. So what's the scenario here? I have Event Grid that sends me lots and lots of notifications from different resources about what they're doing. So say, for example, I have a storage account that's building up lots and lots of images that I'm trying to process. The number of notifications that get sent from Event Grid increases. It's very easy now to hook that up to the auto-scale capabilities inside Service Fabric Mesh to say, I've now got over a certain threshold of events from Event Grid. I want you to go from one instance of my service to 50 instances, processes it, and go back down again. And it'll scale up and scale down within a matter of minutes in order to achieve that. So that those combinations make it incredibly scalable on event-based systems based around Event Grid and Event Hub and things like that. So I think that's a super cool scenario. With the Event Grid, service fabric mesh and functions integration, that combination with storage, putting into remote storage like Cosmos DB is where I think the direction is going for a lot of these high scale, highly available, very fast to develop applications. Yeah, and the key there eventually is that Service Fabric over the years focused on long running services, so it's things that run forever, but we didn't do much on short running. And then functions sort of focused on the short running and didn't do long running. Now we're bringing those together into one world. So I can have one service that's running there for years and another one that launches in a matter of seconds and goes back down again, all running inside the same application. So
yeah, that really seems like the holy grail. Like I just want to write this piece of code that maybe processes these messages, or maybe it just wakes up every 5 minutes and does this thing. And then, like you said, in Service Fabric, I want to also have this service sitting over here that's long running, that's doing some processing. That's great. Because to me, like, I actually just had recently had a conversation about this, and somebody was like, "Oh, there's always going to be this world where you have both of those things," and I'm like, I don't want that. Like, I want
exactly
and I was thinking more of like the containerized world and like Kubernetes. If I have this cluster set up, and 99% of my stuff is running in this cluster, that 1% I'm going to want to eradicate it. And if it's Azure Functions, I'm going to say, hey, I want to get these into container and bring these over. And they're like, why would you want to do that? And it's like, because it's the 1%. It's the leftover bits that I want to get into there. But if you can have all those things, all living in the same world, then that desire goes away. It's like, oh, this is all running in mesh and it all works happily together. That's great.
All right, exactly. And this is the goal around the whole direction of that development. Make it easy to build, highly scalable, highly available applications. Right, just describe things as an ARM definition. Everything is policy driven. I can bring any runtime of my choice. I get all the benefits of the DevOps pipeline, of security. I don't have to think about certificate rollover or certificate management or any of that stuff thing. I get a variety of different storage technologies for my state management. Off I go, and that's the focus of the whole direction of the development of these. Cool. And I think it's super cool. Like we can take runtimes like this. Even in the AKS world, we see people taking functions runtime, putting that inside containers, and spinning it up inside there.
Done.
Exactly. And they too are experiencing that sort of pick any programming model of your choice around and run this inside the environment, the containers.
Okay. Anything else interesting in store for the future then that you wanted to mention?
No, I think that really kind of the investment around Service Fabric continues to be very deep across all our services. It's great that we're having this serverless offering around Service Fabric Mesh. We continue to invest in our current offerings so that you'll see all of the clustering technology there today continue to have capabilities added, and eventually it'll also come to the edge. So we're kind of excited that you're seeing Service Fabric available across all these different environments, and really I'd like to think that over the next year you'll see how you build microservice applications become even easier with things like Mesh, and also even easier with inside Service Fabric clusters that we have today as we add more capabilities inside there. Deep investment across the company on Service Fabric, as well as AKS, as well as App Service. Those three, are sort of the killer platforms that allow us to build all the developer suites that we have.
Cool, very exciting. Okay, Carl, moving on. What do you have for the dev tip of the week?
So this kind of goes back to our comment of the week. When I read that comment from Haken, I kind of did that Windows Control C and just to remember what it was, because I couldn't remember and I didn't see anything happen. And I'm like, that's really odd. So I did a little bit of searching on that. If you're on one of the newer versions of Windows 10, because that was 2 versions ago that he gave us that comment and that we mentioned it on the show. Mm-hmm. But if you do that now, it probably won't work for you. So if you go into Windows settings, search for color filters, you'll see that that shortcut is disabled by default. So you can re-enable that. But
I'm guessing people were hitting it accidentally, or it was mostly being used as a prank.
But, however, this is what's really cool. And I kind of put this in for you, Jason, because I think we discussed on the show before that you have a form of color blindness. Mm-hmm. And now there's some additional options. Instead of just going to grayscale, you can do inverted grayscale, grayscale inverted, or you can add a filter that will adjust the color palette if you have one of those color blindnesses to make the colors more distinct. So it's not to try to correct anything, but it's just to make you visualize and detect those colors a little bit more
I will have to
distinctively.
try that. Because they added it to iPhone like a year ago. And to be honest with you, I actually read about other colorblind people. They were trying this out and they're just like, I don't know what's going on. So I'll have to turn it on here. Color filter. Oh, color filter settings.
Yes. In settings.
Turn on color filters. Whoa. Yeah. I'm instant grayscale now. So if I do red, green.
And it lists them out if you are deuteranopia, protanopia, or tritanopia.
I think of the deuteranopia. I can't remember. I haven't taken the test in a couple of months. I was looking at those colorblind glasses. Yeah, it's hard to tell. Oh yeah,
but anyways, it also provides a color wheel there. It provides a color wheel there for you too. And even if you don't have those color blindnesses, you'll see that some of them
wasn't even looking
easier
at that.
and harder to distinguish from each other.
Oh yeah. So they don't make it. There's no way to see it with it off though.
Yeah, you just do Windows Control C then.
No, because when you turn it off, the color wheel doesn't change.
Oh.
Found a bug. We need a colorblind person working on this feature. Clearly. Yeah, because it turns.
You should volunteer,
weird.
Jason.
So it's on. So it turns it on. And I can see it turning it on and off in the system. Oh no, it does turn it on and off. Okay. It's just such a tiny difference with that red-green mode. But my screen isn't big enough. I can't look at the color wheel while I'm doing it.
Well, anyways, I thought this might be useful for people, who have a form of color blindness or is wondering why their grayscale isn't working anymore.
I definitely, on the protanopia, I can definitely distinguish the colors, whereas I can't on whenever it's turned off. I mean, like it's really hard to distinguish. Actually, there are two on there that I literally cannot distinguish unless I have that mode on. So I guess it works. So it's just going to look really weird. It's going to be one of those things when somebody else sees it. So yeah, I have to do the red-green protanopia. Some of the stuff in Windows looks kind of funky, but I actually can distinguish all the colors then. That's pretty cool. I'll have to remember that because the time that it always comes into play is in charts. Because they'll have two different lines and they're the same color to me. So very cool. Anyway, Mark, where can people find you?
You can contact me on at Twitter at mfussell, MFUSSELL,
Okay.
or that's the best way of contacting me. Or you can just tweet as well at Service Fabric as well. And we always kind of spend a lot of time kind of following the Service Fabric Twitter and replying to questions inside there.
Very cool.
So yeah, reach out to me,
ahead, Mark.
please.
Yeah. And we'll have links to like everything in the show notes, everything that you've been talking about. And Carl, where can people find you?
You can find me on Twitter at Carl Schweitzer.
You can find me on Twitter at twitter.com/ytechie. So Mark, thank you so much for coming on here and talking about Service Fabric Mesh. This is super cool and I'm excited to try it out.
Thank you.